Hi everybody, and welcome to our second lesson talking about angles. So last lesson we talked about reviewing what complementary, supplementary, and vertical angles are. And today we're going to talk a little bit more about angle relationships when it comes to transversals. So let's start out just defining what a transversal is. So a transversal is when you have a line that intersects with two or more other lines. It intersects with two or more other lines, and by intersects, it just means it crosses through. So let's take a look at an example of a transversal. So here we have a transversal, and this transversal is in green. So this is the line that is crossing through, intersecting with two other lines. And here we have an example of a transversal of two parallel lines, and it's creating four angles. So you can see that when you have a line intersecting with other lines, with each line it intersects with, it makes four different angles. And you have two sets of angles that add up to 180. So all of these angles together are 360 degrees, makes a full complete circle. And because our transversal intersects two different lines, it's making 8 angles. So with transversals, what we have first, the kind of angle we're going to talk about is corresponding angles. So corresponding angles are angles that are in the same location at different points of a transversal. So the important idea here is that these are angles that are at the same location at different points, different intersections of a transversal. It's really important to recognize that when you have a transversal of parallel lines, these angles are congruent. So let's take a look at an example. So here we have our diagram of our transversal again, and we're going to take a look at some examples of corresponding angles. So again, this is a transversal of parallel lines, and let's look at our first set of corresponding angles. So angle 1 is in the upper left-hand corner where this intersects, this transversal intersects. So now we need to go down to the next place the transversal intersects and go to that upper left-hand corner. So because these lines are parallel, this transversal creates two angles that are congruent with one another. They're the same size because they're in the same position in this transversal. So now let's take a look at angle 2. Angle 2 is in the upper right-hand corner of this transversal intersection. So if we come down here, the angle that's going to be congruent with it, its corresponding angle, is also in the upper right-hand corner. It's the 6. And we can do that with 3, that lower left-hand corner. That would correspond with this lower left-hand corner, number 7. And we can do that with angle number 4, our lower right-hand corner. That's going to correspond with this lower right-hand corner, angle number 8. So it's important to remember that corresponding angles are congruent when your transversal is going through parallel lines. The next important type of angle pair is called a linear pair. A linear pair is two angles that are adjacent, they're touching one another, and they are supplementary. They're going to add to 180 degrees. So these pairs of angles that are beside each other, they add up to 180. They're found in a transversal. So let's take a look at where they are. So here we have that same transversal. We're going to look for linear pairs. And there are a ton of linear pairs here. So the thing is that linear pairs can be horizontal and go side to side, or they can be more vertical and go up and down. So one really good pair of vertical angles to start out with is 1 and 2. So angles 1 and 2, they're adjacent, they're touching one another, they're supplementary, they add up to 180 degrees. You also have angles 3 and 4 that are linear pairs. So here on this top part of the transversal, you can see that you can have horizontal pairs of linear pairs. So now let's look at our vertical or up and down linear pairs in this bottom transection. So you can see angle 5, we know it's in a linear pair with angle 6, but it is also in a linear pair with angle 7. We can see here angle 6 is in a linear pair with angle 8. So it's important to keep in mind that it can be one or the other. So you can say, okay, angles 1 and 2 are in a linear pair. Angles 5 and 7 are in a linear pair. You could also change your mind and say that angles 5 and 6 are in a linear pair. So those are also adjacent and add up to 180 degrees. They're supplementary. But what you don't want to do is name the three angles together and say 5, 6, and 7, because yes, they're all adjacent, but they add up to more than 180 degrees total. So it's important to keep in mind that your linear pairs can be horizontal, they can be vertical, but there are only two angles. They're adjacent, they touch each other, and they add up to 180 degrees. Next, we have a specific type of linear pair. It's called a same side interior angle. So this same side interior angle is a linear pair because it's adjacent angles and they're supplementary, but they're on the same side of the transversal. So again, linear pair, but they're on the same side of the transversal. So let's take a look at an example of this. So we remember our linear pairs are just adjacent angles that are supplementary. And the one extra thing we add in when it's a same side interior angle is when they are on the same side of the transversal. So if we start with angle 1, what we're looking for here is an angle that is supplementary and adjacent. So either 2 or 3, but it needs to be on the same side of the transversal. So, well, this is on the left. This also needs to be on the left. So 3 is that same side interior angle. If we were talking about angle 2, well, it is supplementary with 1 and 4, but it's on the same side, the right side of the transversal with 4. So 4 is its same side interior angle pair. With 5, our same side interior angle pair would be complete with 7. And I'm sure you can guess 6 would pair up with 8. So again, you're going to see that this feels really similar to those linear pairs because a same side interior angle pair is a type of linear pair. The next important kind of angle relationship, it's called alternate interior angles. So alternate interior angles use both the idea of corresponding angles in linear pairs because they are two supplementary angles, but they just happen to be on different places in the transversal. So these angles are supplementary, they add up to 180 degrees. And let's take a look at how they use corresponding angles in linear pairs. So we're using the same diagram we've been using, and so we're talking about alternate interior angles, and it uses the idea of corresponding angles. So we've got our corresponding angles, 1 and 5, and it also uses the idea of linear pairs, angles that are adjacent and add up to 180 degrees. So you can see here with the red circles, we have our corresponding angles. They're in the upper left-hand part of the intersection for that transversal, here and here. And then we have a linear pair, 2 adjacent angles that add up to 180 degrees. So what we do here is we are using these ideas to realize that we know 1 and 5 are the same size and 5 and 6 add up to 180. So our alternate interior angles are 1 and 6, where they aren't in the same place on the transversal, but they do add up to 180 degrees. And the important piece here is they're on opposite sides of that transversal. So again, we know that these are alternate interior angles because they meet the 3 requirements. They are in different places on the transversal. So we've got one up here where it intersects this line, one where it intersects the second line, They are on opposite sides of the transversal. One is on the left, one's on the right. And finally, they add up to 180 degrees. They're supplementary. And we can prove that these are supplementary because we know angle 1 is congruent to angle 5 because they're corresponding angles. And angles 5 and 6 are supplementary because they are a linear pair. So as 5 is the same as 1, then that means 1 and 6 add up to 180 degrees. So now we're going to use the ideas of those corresponding angles, alternative interior angles, same side angles, and what we knew from before, our vertical angles, supplementary angles, and complementary angles. And what we're going to try to do is we are going to try to solve for A through K. So I like to start by finding all of my vertical angles. So I'm going to mark those off in blue to show you that we found them using vertical angles. Well, I see that A shares the same lines that form it with 60. So A is 60 degrees. I can see that B is a vertical angle with 65 because it shares these two lines that form it, so that's 65 degrees. And C is a vertical angle with this 55 degree angle, so it's 55 degrees. And we know that because all vertical angles are congruent with one another. So next, I'm going to look for corresponding angles, angles that are in the same place in a transversal. So I'll mark those in maroon. So I see that these two lines right here are parallel. So this right here, you can find some corresponding angles. And I can see that the lower right hand of this transversal is 60 degrees. So I know K, the lower right hand of this transversal, uses the same transversal and the parallel lines. This is also going to be 60 degrees. I can see for 60 degrees and H, A and H, those are also corresponding angles. So H is 60 degrees. And we can confirm that because H and K are vertical. We can then use linear pairs to figure out what I and J are. So I know that H and I have to add up to 180 degrees. So I know that if H is 60 degrees, I must be 120 degrees. And the same must be true for J, because K and J add up to 180 degrees. If K is already 60, then 180 minus 60 is 120. And we can confirm this knowing that I and J are vertical angles. So one of the last things we can do, we can start using alternate interior angles. There are a couple other ways you could figure these four out, but we'll use alternate interior angles just to make sure we know how to use them. So I know that we're going to focus on these parallel lines being transected by this line right here. And I know that this line, transecting this is 65 degrees. And so its corresponding angle here, D, would be 65 degrees. But I know its alternate interior angle pair would be F, right? Because they are on opposite sides of the transversal. They're going to add up to 180 degrees, and they're at different points in the transversal. So if B plus F is 180 degrees, then F is 115 degrees. So we've used all the kind of angles we know how to use, and we can complete this using vertical angles. They're one of my favorite ways to use angles because they're the easiest. I know D and G are opposite one another. They share those same lines. So G is the same size as D. They're congruent. 65 degrees. And the same can be said for E and F. So E must be 115 degrees. So this is how we can use all of the types of angles we know: vertical angles, complementary, supplementary, linear pairs, corresponding angles, same side interior angles, alternate interior angles. We can use them to figure out the measure of all of the angles we make in a transversal, where we have a line intersecting with two or more lines. So I hope this was helpful to teach you a little bit about transversals and how to use them. So have a good day and work hard.